Hi Raj, in functions 3 we're going to look at exponential equations, a really important skill for Leaving Cert. We're going to introduce solving them using log rules. This is when we have y is equal to, let's say, 2 to the power of x. It could be written as b to the power of x. And then we're going to look at natural log rules when we have y is equal to e to the power of something. It could be b times t, where t will be time. We'll introduce y is equal to ae to the power of bt, which comes up every year. We'll look at a little bit of calculator use, making sure you know where e is. We're going to look at the 2021 exam question, which had 4 questions, kind of 4.5, 2 shorts and 3 longish parts worth 40 marks out of 220, 18% of the paper, which it pretty much is every year for really this knowledge that's in this video about exponential functions. So, you know, a fifth of paper 1, if you know this stuff, you're going to go straight to this question at the beginning. We're going to make sure you have a knowledge of whether this is growth or decay that we're dealing with within these questions. And then we're going to look at sketching these exponential functions. So maybe just jot down what we're going to do first, and then we'll have a look at solving them to start this video. So if you're asked to solve a y equal b to the power of x question, this is our exponent. So what about a question we already know the answer to? What about, we know that 2 squared is equal to 4. So just your basic log rules. If we bring x in front and get the log of 2, or as I explained, the log of both sides, x times the log of 2 is the log of 4, and then we divide by the log of 2. We type into our calculator the log of 4 divided by the log of 2, and we get an answer of 2. Now check on your calculator. That a lot of people will question, is this the same? Is this equal to log 2? Check log 2 in your calculator, Raj. C is equal to 2 for me. And then write down the answer and make sure you write the log of 2 is equal to 0.301. So just understanding that log 4 over log 2. These are dealing with a base number of 10 in here. These things in maths that we don't see. This is not equal to the log of 4 divided by 2. So don't make that mistake within these questions. So why don't you try, maybe I'll write a couple down and you try them before continuing. Okay, Raj, so try these two. 7 is equal to 2 to the power of x. So what you should write down, x by the log of 2, I will switch sides, is equal to the log of 7. So x is equal to the log of 7 divided by the log of 2. Type it into your calculator, x is equal to, and you know from before it's not the same as the log of 3.5. Type this into your calculator and get 2.807. What I do here is I type into my calculator log 7 equals, get my answer, and then I type divided by log 2 equals, and I always kind of break it up into 2 parts just to save any mistakes happening with order. And then I'd always check here, what is 2 to the power of 2.807? And I would write that down, Raj, 6.998, which you know is equal to 7. So you're just kind of showing to yourself as you're practicing these questions, yes, I'm going back, I'm checking my work, I'm slowing myself down enough that I can see what's happening within the question, and I think I would recommend doing that. So then try 3 to the power of x equal to 81. So x log 3 equals log 81. The reason I'm focusing on this rule is it comes up every single year more than any other. X is equal to log 81 divided by log 3. And here you're going to get an answer of 4, because 3 to the power of 4 is in fact 81. Now there's another button on your calculator This stands for log naturale, the natural log. And we're going to show that we can actually use this rule here too. If we take 7 is equal to 2 to the power of x, what happens if we get x by the natural log of 2? Is that equal to the natural log of 7? So try in your calculator. The natural log of 7 divided by the natural log of 2. See, you get 2.807. And then what you'll decide is, am I going to use ln or am I going to use log? And that's up to you. You can do it either way, and in some videos I do it one way and in some videos I do it another way, Raj. Whatever you decide to do, you're going to decide, am I an ln man or am I a log man? And you can see that yes, this is the case. So you decide what are you going to be. So the reason I'm introducing this natural log is based on this equation that we're going to see when we look at the 2021 exam question. Every exponential equation can be written in the form y is equal to a, and it's normally a capital A, but it doesn't have to be, ae to the power of bt, which is just an expanded version of this. So this is my base number e, my exponent is in 2 parts, and t is always time. So that's where these questions are going, and I'm going to introduce you now into just solving e to the power of something using natural logs. And you're understanding that I want you to jot down that the natural log of e is equal to 1. We're going to use it in the first few, and we're going to continue to use it all the time, just so we're following the same rules all the time, and you're always thinking of the rule that you're following within the question. So I'm going to get you to solve this, but before you do that, Raj, will you please check in your calculator, e to the power of 1. So normally when you put e into your calculator, this box appears here, so you always have to give it a power. So e to the power of 1 is this magic number that if you go on and study financial maths you may use in compound interest, 2.718 281 828 281 828. Now we never need to see this number, so what I want you to do is remember that e to the power of 1 is 2.718, and that's what I would round it off to when I'm using it, kind of just estimating stuff. So you could do trial and error here. E to the power of something is equal to 7, or you could just say ex, if you use your log rules, x by the log of e is equal to the log of 7. And now just pause what you're doing and off to the side on your calculator, check what log of e is, and when you put it into your calculator you should get 0.434. And while we're at it, what I want you to do now is check ln, and both of these cases you do have to put this power of 1 in, and if you type ln to the power of 1 in your calculator you're going to get 1, which we're going to come back to in a minute. So just solving here, x is equal to the log of 7 divided by the log of e, which on your calculator will give you 1.9459. There's a 1 after that and a 0, so we can just leave it at that just for now, because we're going to check here. Put back into your calculator, e to the power of 1.9459. Round it off slightly on purpose just to see that you get a number that's pretty close to 7. So hopefully you get 6.9999. So you can see just this lesson in, we don't need this 1 and 0. We get really close. Raj, I know that you gave me a question one day. I think you had rounded off to about 34 decimal places. So we never really need more than 4. You can see here that it doesn't make much of a difference. Now let's jump to natural logs when we're using e, which is, I think, going forward probably the way that you're going to do it. So we can use ln, natural log, x ln e. You saw that we could use that as well from the other one. X ln e is equal to ln 7, the log rule that we're going to see all the time. Ln e is equal to 1, so x is just equal to the natural log of 7 in this case. And if you type the natural log of 7 into your calculator, you will of course get the same number that you got up above, and the 10149 at the end, which we don't need. So you can see going forward we're going to start using natural log instead of log. Okay, Raj, before we go into the exam question, let's kind of look at where they get them from, and we can kind of bring some meaning to this question as well. So if you're asked to solve this equation here, y is equal to 20e to the power of 5x for y is equal to 10, you'll put 10 in for y, substitution, which comes up all the time, is equal to 20e to the power of 5x. The reason I'm putting this in is this is going to be my big A that we saw a minute ago. We can divide by this number. We cannot divide by an exponent, as you already know. So you could write 10 over 20. You could also write at that point 1 over 2 or 0.5. Just don't jump too quickly and make a mistake. So 10 over 20 is equal to e to the power of 5x. And you can see now, if you want to write 0.5, you can. I like writing 0.5, write whatever you want. But you can see now we're back to a really simple question that we began the lesson with. So that's what these questions always are. They're going to look confusing, but they're not. So using ln, we're going to get 5x ln is equal to ln 0.5 using our natural log rules. So x is going to be equal to, you can see here, the natural log of 0.5 divided by this 5 natural log of e is equal to 1. If you want to write 5 ln e, you absolutely can. And typing this into the calculator, you're going to get x is equal to. And what I'd recommend on a calculator, Raj, is that you type in ln 0.5 and you're going to see it coming up on the calculator as a minus. This is equal to a minus number. It's going to go on 0.693. So just identify what it is. Make sure if you're typing in the natural log of a number, and we'll see this with inequalities, that's between 0 and 1, it's going to be a negative number. It's like 1 over the power of something or 10 to the power of something. So the natural log of 5, just you can hit equals. I would when I'm using natural logs, and then hit divide 5. And you should get a negative answer here. And let's understand why, so don't panic in exam saying things can't be negative. Of course they can. 0.138629, and with these powers they normally ask the 5 significant figures. So this will be minus 0.13863, correct 5 significant figures. Now, why is this a minus? And the understanding of this makes these questions really easy. I'm just going to replace this y up here with a 10. And we can see here, if I write my equation, y is equal to ae to the power of bt that we had a minute ago. This is what all of these exam questions are going to be based on. My amount now is 10, if I think about it like this. My initial amount, which we're going to describe it as going forward, was 20. So if I started with 20 and I now have 10, we can see I have a declining exponential function. So I'm going to get this negative down here. I'm going to get a negative k or a negative b. So just identifying and understanding what this function is when we have this negative inside it, this 5x, we couldn't see it was negative in the question, but we know as we're about to solve it that it is negative because of the 10 and because of the 20. So let's have a look now at 2021 and see how we got a positive and negative function and how easy it is, Raj, to pick up 40 marks when you practice these questions, and have no fear. So Raj, if you think you get them, let's have a look and see how they always ask this question pretty much every single year. This year it's a cup of coffee, 2021. It says 50 marks here, but we're going to look at 40 of them. The last 10 were for a chain rule differentiation question. So they dress these questions up to be like real life situations. This is the whole new project math since 2010. In this case, a cup of coffee, freshly brewed to 95 degrees centigrade. the hardest thing about these questions is to actually understand what's being asked. So read it really carefully and underline what you're given. The temperature T, down to the equation, here's temperature T, written as T of T. And this T in here is going to be time. We're going to put a T into our BT part of the exponential equation, and then we're going to get a temperature out. So it's like putting an X value in, we get an answer out for Y. Here we're putting a T value in and we're getting an answer for T. So slightly confusing in that case that there was two T's in the question. Usually we have F of X, here we have T of T. So this is what I was kind of saying earlier, is don't get confused by how the question is phrased. You know, when you see this question, same as it always is. I've done loads of these. It doesn't matter whether it's coffee or the temperature of orangutans living in trees or the temperature of golf balls as they're hit by a golf club. It's anything to do with anything going up or down. We can use this equation. So part A is show that A is 75, and it says here A is constant and T is time measured in minutes from when the coffee was brewed. So T of T is equal to this whole expression. I would always recommend write that out straight away. T of T is equal to AE to the power of minus 0.0881T plus 20. Now don't put the plus 20 up here as some people did in the exam. The plus is clearly not beside the T. So a cup is freshly brewed to 95, and in all of these cases the first part has to begin with time equals 0 or we can't figure anything out. So initial is time equals 0. So that's temperature big T when time is 0. See how it will confuse people? Is equal to A E. Now it doesn't matter about the minus 0.081. If we have a 0 for T, it's A to the power of 0 plus 20. And we're told that this is equal to 95, my initial temperature. It's all about initial T. Look for the words initial temperature, initial time. So you can see here that A E to the power of 0, I would show the examiner, I'd leave the E to the power of 0 in, is equal to 75. E to the power of 0 is equal to 1. I would write that down. E to the power of 0 is equal to 1. Therefore, A is equal to 75, which is what you were asked to show up here. Q E D quad erat them and strand them even. You don't have to say it out loud in the exam, just write it down on the exam paper. So Raj, exam technique is vital. It's all very well being able to solve the questions sitting at home, but you have to be able to show the examiner what's required, and by practicing the questions you know what's required and you're going to repeat that information in an exam under pressure, just like you're doing sitting at home. So what about part 2 here? Explain what the value 20, now these can be a little bit confusing. Explain what the value 20 means. This is an English based answer, which I find confusing. So what is the English based answer? So the temperature in degrees centigrade of the coffee as it cools is given by the formula. A is a constant, T is time. So what is this 20 at the end here? This is what they're looking for in the context of this question, is the temperature of the surroundings. So just to show you, Raj, in case you're not looking how the marking scheme would look, how are they given here? They're given 5 marks for this question. Any valid description, the lowest temperature the coffee will cool to. You can see not a lot of words required. The lower limit of the coffee's temperature. Room temperature, which is the one I kind of was thinking of. So any valid description is 5 marks for top marks and 2 partial credit. Reference the temperature or limit. So using mathematical terms, and you can see the marking scheme if you want to have a look at it for the first part there. You can get 0, 2, 3, 5. I'm going to introduce this marking scheme as we go to show you how easy it is to pick up marks. So part 3 is worth 10 marks. Find the decrease in temperature of the coffee 10 minutes after brewing. So you're putting 10 into the function, write it as T of 10 is equal to 75e to the power of minus 0.081 by 10. Make sure again you don't put the plus 20 up here, plus 20, and from here it's just calculator use. I wouldn't do it in two parts. I just type it in twice and see what I get. Make sure you get the same answer twice, Raj, as I always keep on repeating. You've probably got a headache from listening to me, but it does need to be said over and over again to always double check on the calculator. And the answer here is 53.364, which I'm just going to triple check. And then I'd move on without reading the rest of the question and lose marks, because it says find the decrease. Now it started at 95 as we know initially. It's now 53, so what has it gone down by? And it's to the nearest whole number here, so 95 minus 53 is going to be 42. Or I probably should write the 41 point, what would it be, 636, and then write the 42 underneath for good maths. So that would be the decrease in temperature, 42 degrees centigrade, I think we're dealing in here. So exponentials shouldn't be too difficult, Raj. Substitution, solving. In this question part B, we're solving for find the time, and we're told ideally it's 82. So 82 is the temperature, and you've seen this from earlier on in the video, how to solve these questions when we're dealing with 0.081. The most important thing is to actually write the question down. Minus 0.081t plus 20. When is this equal to 82? We're solving for time, so you know it's your ln or your log, whatever you've chosen to use. So the first thing to do here is to take away the 20, and we're going to get 62 is equal to, now it's equal to the whole right hand side, but at this point you should notice that you can divide by 75, at least do that step in one go, minus 0.081t. So now I always start with writing the right hand side. I'm bringing this in front, the minus 0.081. We're going to get it two negatives, you can see from the fraction here being less than 1, and that's t by lne. I still would write the ln out, Raj, even though it's equal to 1, as you already know. That's equal to the natural log. I come back and write the natural log of 62 over 75. So then I'd write in an exam the natural log of 62 over 75. I put a big line for my divide. The minus two negatives are going to give me positive. We couldn't get a negative for time. If you do, go back and double check. This is equal to t. And then just write your answer down for simple 10 marks. You can see why I'm showing you these exam questions is that people overcomplicate logs and think that they're very difficult, but you can see the exam questions are really, really straightforward. And that's 2.35, and time is in hours. Now, I hope, Raj, that you are already looking at the marking schemes in all your subjects, but just to show you what is actually given here in the marking scheme. So you can see here 2.35 is equal to 2 hours 21. You just do your 0.35 by 60 to get 21 minutes. Sorry, 21 seconds, Raj, 2 minutes 21 seconds. And what was accepted here? The 2.35 was accepted, or 141 seconds. So don't be too stressed out if you're not converting time at the end. If you're stuck for time, just make sure you're focused on getting the first part correct. And Raj, I'll just show you part C here. You already know calculus. It's this T prime T. Find to the nearest centigrade the temperature T prime T, which I'm not going to do with you, the rate of cooling. We'll do that within the calculus section, but you can see how they're going to link your functions questions into your calculus questions in paper 1. Raj, I'll finish up this video before making a video on inverse functions, just with sketching a few of them. Now, let's say our inverse function, or our function, exponential function, looks like this. This point here will be what number? Now, they're all written in the form y is equal to ae to the power of bt. I've mentioned the initial amount a already. If this was just y is equal to e to the power of something, e to the power of 0 when x is equal to 0 at this point is always equal to 1. So that number is always 1 or the initial amount a. So you could see this graph given here. This could be an a or an initial amount. So let's sketch one that's coming down. Again, what amount is that going to be? It's going to be my a. Is it going to reach this x-axis along here? It's not. So what does this line become called? This x-axis is an asymptote. Just introducing that today. Asymptote, this line that this line is going to converge with. There will be a limit, which we're going to see in calculus, but it's also part of functions. So an asymptote, again, this is a, it could be 75. What do we know about this graph? We know that b is going to be less than 0. This letter in here. Now, Raj, what I want you to do for the last part, this is a coffee cooling question that came up a few years ago. I want you to try and create an equation here for this y is equal to, or create your own question. Let's say something starts at 50. What could it be? 50 e to the power of, what's your negative 0 point something, let's say you're going to make it up here, and then time always comes into this question. And the way that they can make these questions difficult in an exam, they could say, well, maybe this, we have the same initial point. What would it be happening along here? This is cooling quicker. And the question that came up a couple of years ago is come up with a new value for b or k that would make something cool quicker. So that's what I want you to do to challenge yourself before we meet in person on this, which we will after you've perfected these videos on functions. I want you to create the question that you're going to show me. It's the first thing I'm going to ask you when we meet. You're going to show me what question you've created, what real life example you've given it, and then I want you to create one in a positive sense too, and explain to me your in-depth knowledge of exponential functions.